Meron na naman tayong bagong project. Ano na naman yan? Aba, bago ito. Meron tayo dito mga discrete components. Diba? Yan o. Transistor, LED, resistor, switches. Jumper wires at breadboard. Ano yan? Ito ay NAND gate. Ano na namang gate yan? Wala namang gate dyan. Aba, lagyan natin ng 5 volt supply. Power bank. Para malaman mo itong NAND gate. Nakikita mo ba yan? Umilaw na yung output LED. Power LED. Bukas na yung circuit. Umilaw na yung power LED. Yung output LED, umilaw din. Oy, ano na naman yan kung umilaw yan? Dito, gagamitan natin ng switch. Ito, turn off natin ang output LED. Subukan natin. Pindutin ang switch 1. Input LED umilaw, pero buhay pa rin ang output LED. Release. Pag pinindot ko yung switch 2, buhay pa rin ang output LED. Oy, paano naman yan, mag-o-off? Ha? Oy. Sabay nating pindutin. Off na yung output LED. Pag nirelease mo, mabubuhay na muli. Diba? O, yan ang natawag na NAND gate using transistor. In figure 1, we have the NAND gate schematic diagram. Using transistor. We are using transistor to make a NAND gate. What is the purpose of a gate? What is the gate? What do you think is the purpose? Or what is the use of gate? Gate is used as a switching circuit. And in our case, we are using a NAND gate. In NAND gate, we also have a symbol. An AND gate with a bubble or with an inverter into the output. Supposedly, this is an AND gate with inverter. So this is a NAND gate symbol with 2 inputs, A, B, and output of Y. So A, input A is switch 1. And then input B is switch 2. And what is the output? Where can we find the output? Y. It is located here into the LED to the ground. That is the output Y. It also has a truth table, NAND gate. It consists of 2 stable state. A low level, 0, which is equivalent to a low level, low logic level, or almost ground, or 0 volts, or low level. And then 1 is 5 volts, or high level. low level, that is a 0. So if we are using, if we did not press the switch, it means it has a logic level of 0 volts. If we are not pressing the switch, it is grounded. So since we are using a discrete components, transistors, resistors, and LED, the transistor is grounded, considered as logic level 0. It is grounded by a resistor and LED white. And this component that makes this transistor to be grounded is also an input LED. Because once we press the switch, let us see. Once we press the switch, we're going to inject a current 5 volts, since 5 volts our source, to the base and into the LED. It will turn on this input LED. So when we press the switch, it means we have an input of 1. So if it is 0, it is grounded. Same with the transistor 2, grounded. And then we have this power LED consisting of 5.6 kilo ohms and red LED. To the switch 2 also, we have this to the switch 2 we also have this low level or ground level. Switch 2 is B. We also have the high level, 5 volts, equivalent to 5 volts and ground. And then we have another transistor which is connected to the emitter of the first transistor. And then a resistor, 100 ohms. This configuration is a common collector type configuration of transistor. And then the output, we have the LED and also a resistor connected to the collector and into the supply. Let us use the truth table. What is the purpose of truth table? Just to know the situation of the circuit. When we press when we have a 0 to the switch A and 0 to switch B, it means we did not press the switch. It is grounded. Our output is 1. It means a high level. There is an output. What is happening here? Without pressing the switch 0, A and B, still there is an output 1. That's why we, in our demo, we have an output or LED turns on. Why is it that LED turns on? Because since switch 1 is open, transistor 1 is open. Switch 2 open, it makes transistor 2 open. And what will happen to transistor 3? I'm using a NPN type BJT transistor for all the transistor. What will happen to the third transistor? It also open. As long as there is no current to the base, current will not flow from collector to emitter. No base current, there is no collector to emitter current. That is the ruling using this transistor. So if this is open, what will happen is the current is flowing from 5 volts to 470 ohms, then to the LED, then to the ground. It makes to turn on this LED. That's why we have a high level. 1. It means LED turns on. There is an output. Why? Because all transistors are open. So what happened now if we're going to press the switch B and we did not press the switch A? So when we press switch B, current flows into the 3.3K resistor. LED blue turns on because this is an input LED. And do you think current will flow in this direction? The current will not flow into this direction, and then it is looking for a ground somewhere here. This is the ground, the closest ground. Current will not flow into the emitter to collector, then to emitter into the ground because switch A is open. There is no current flows into the switch on. So current will only flow into the input LED, turning this input LED blue, and it will not, current will not pass to this transistor. It is still open because there is no current here, collector to emitter, then to the ground. There's no base current here. It's still open. That's why current still going to the output, still 1. While pressing the switch 1 or A, this is now 1, high level. It means we are injecting a current, and switch 1 is on or close. Current flows into the LED white, so it turns on the, that's why we have seen that the LED white turns on because of switch is on. Do you think current will flow to this transistor and then to the ground? It will not flow because there is a base current, but there is no collector to emitter to the base, to the ground. So current will not flow to the output side of the transistor because this transistor 2 is open. Now this is open, this is closed, still output is 1. Current flows into the out, to the base, to the 5 volts, to the 470, and then to the LED. Now, let us consider the case if we are both pressing the switch 1-1. It means we are injecting a high level, logic level, to the transistor 1 and transistor 2, 1 and 2. When we inject a current here, it will produce a base current to the transistor, turning this transistor on. So this transistor on 2 or 1 is on. This is also on. We're injecting a current. If this is on because of the base current, and this one is also on because of the base current, current now flows into the 100 ohms collector emitter, and then to the R6, the resistor. What is the use of this resistor now? This serves as current sense resistor. So all the current will now go into this branch. What is the use of the resistor here? That is the base current, base resistor, or the bias resistor, in order not to damage the transistor. And this one, coupling, a coupling resistor. So all the current flows here, and then it will now provide, or the current will also, the current also flows into the 5 ohms, making this transistor to turn on. If this transistor 3 turns on, current now flows into the 470 ohms, collector to emitter, and then to the ground. This transistor now turns on, making this LED to bypass, so it will not turning on, or it will turn off. That's why we have this 0 or low level, or off, or grounded, no voltage, because all the current flows from collector to emitter because we have now the base current due to the 2 transistors are now active. Okay? And because of that, we have the output of 0. It will make the LED output to turn on because we are pressing both the switch. Okay? Oh. Pressing the switch. We both press the switch. 1, 1. It will produce an output of 0.